All right, so what we're going to be doing today in lesson 3.3 is solving multi-step equations, all right? What that means is we're taking the information that we learned in 3.1 and 3.2 and we are doing more than one step. If you remember in 3.1 and 3.2, we said, okay, if it's y plus 6 equals 12, I subtract 6 and I get y equals 6. That's a one-step equation. That's what we learned how to do. We learned how to do addition, subtraction, multiplication, and division, and then also multiplying by the reciprocal. All right, so we're going to do just a quick little review. You don't have to write these down. We're just going to do these together in class. All right, Hannah, on this first problem here, in order to solve for x, what would I do? Divide by 9. And again, you don't have to write this down. We're just kind of doing it together. And what would x equal? 9. Okay, so that was our one-step equation, just like what we did. Dean, what would I do on this next problem to solve? Multiply by 12. Exactly. Multiply both sides by 12. And I get x equals what? 60. Okay. Megan, what would I do on this next problem? Perfect. Multiply by the reciprocal, which totally cancels out. Multiply by the reciprocal. Okay. And I get x is equal to, the 3's cancel out, and I get x is equal to 4. Okay, so that was our review from 3.2. 3.1, remember, we just had addition and subtraction. So we either added to solve or subtracted to solve. So in 3.3, this is what you have to know. Everybody write this sentence down. Everybody write this sentence down. You have to get this in order to get this lesson. If you get this, I have no doubts in my mind that you will be very successful doing 3.3 and 3.4. Always combine like terms first. Always combine like terms first. Okay, what that means is in multi-step equations, I'm going to have different numbers, different terms, okay, that need to be combined with one another before I can say x equals this, okay? So that's what that step means. If you remember, always combine like terms first, you will have no problem solving these equations, okay? One other thing that I want you to remember is like terms can be on both sides of the equation. And you say, well, what do you mean by both sides of the equation? Okay, look right down here at the bottom of this slide, and I'm going to write, let's say, 3x is equal to 2 plus 6x. Okay, what are my like terms in this problem? Jensen?
3x and 6x.
3x and 6x. Are they on the same side of the equation? No, because this equal sign right here tells me the 3x is on the left side and the 6x is on the right side. So don't think that, oh, like terms mean in order to combine them, they have to be on the same side. No, we would have to combine them even though they're not on the same side. Another good one, all right, that people get confused on, they go, hold on a second, what do you mean? If I had this, wait, hold on. If I had this problem, what are my like terms in this problem? 3 and 6. You say, but wait a second, I thought a like term meant it had to have a variable. No, terms without variables are also like terms. Again, those are on opposite sides, but I still need to combine the like terms. And that's going to make more sense once we actually get in and you can practice it and start solving it what we mean. But just remember, you always combine like terms first, then you're going to also remember that like terms can be on both sides of the equation. So let's start out with example 1 here. Solve the equation. Before I do that, what is step number 1? Combine like terms. Thank you. So, Seth, what are my like terms?
Negative 5 and 10.
Negative 5 and 10. Perfect. Are they on the same side of the equation? No. So what am I going to need to do to combine them? What should I do, Betty?
Add 5.
Perfect. Add 5 to both sides. What happens is that totally cancels out, and I'm left with 5x equals 15. Now, the whole point to solving these problems is so that I get the variable on one side and the numbers without variables on the other. Look at that. I have a nice, neat problem. I've got my x on one side and my number that does not have a variable on the other. That's the whole point of that first step. That's why I do it, okay? However, another thing that people do is if this was my problem, I'm just going to rewrite the one that I had. I say, okay, negative 5 and 10 are like terms, so I'm going to subtract 10 on both sides. Okay, let's say we did that. 5x minus 15 equals, what's left over there? Nothing. You cannot do that. Remember, the whole point is to get variables on one side and numbers without variables on the other. That way I have a nice, even, organized equation. I can just do my one step and solve. Okay? Now, let me go over one other thing that people make. This is the number one, okay? Number one multi-step equation killer. Number one multi-step equation killer is people look at this problem right here. And they go, I need to get x by itself, so I divide by 5. Wrong. No, 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 no. If you do that first, your whole entire problem is wrong. There's nothing, there's no points I can give you. There's nothing that you did right. You have to, remember that statement I told you, always combine like terms first. Okay, so let's finish this off and solve this problem. What am I going to do to get x by itself? Divide by 5, and x is equal to 3. Okay? Let's do this next one. Jason, what are my like terms? 20 and 62. Perfect. Samantha, what would I do to combine those like terms?
You subtract 20 on both sides.
Perfect. Subtract 20, which cancels it out here. Now I have 6x is equal to 42. Okay, now I've got my variables on one side, my numbers on the other. I have a nice, neat problem. And what would I do, Janae? Divide by 6. Perfect. And I get x is equal to 7. Okay? You can check these exactly like we checked our other ones. I suggest you're allowed to use a calculator on all of this stuff now. So, plug it into your calculator. 6 times 7 is 42, plus 20 is 62. Yep, I know I did it correctly. Okay? All right, now let's look at this next problem here. What would I do first, Hunter?
Add 5 on both sides.
Perfect. Add 5. I've got to combine like terms, so I add 5. Now I have 1/2 x is equal to 15. What would I do now, Tristan?
Multiply by the reciprocal.
Perfect. Multiply by the reciprocal. The reciprocal of 1/2 is 2 over 1, which is also known as what? 2. So I can just multiply this side by 2 instead of making it 2 over 1. I mean, you can make it 2 over 1 if you want. It's not going to do anything different to the problem. It just makes it a little bit easier when you write it as 2. So x is equal to what? 30. Okay? So in example 2, we're doing more of the same thing. I've got to combine like terms first, then I can solve the problem. Okay? Everybody think about what we've been doing first. Have I ever divided at the very first step of a problem so far? No. We always do addition and subtraction first, and that's the same thing as combining like terms. So think about it this way. If I ever start off my problem with division, odds are on a multi-step equation, you've done something wrong. Okay? You always want to do addition and subtraction first, and then your very last step you divide or multiply depending on what's in front of the variable. Okay? Jensen, what are my like terms in this first problem?
7x and negative 3x.
Okay, and
Negative 8 and 24.
negative 8 and 24. So I've got more than one pair of like terms. That's perfect, okay? In order to combine 7x and negative 3x, would I need to go, okay, plus 3x plus 3x? Would I do that? No. The only time you use inverse operation is when you've got to move something from one side of the equation to the other. If it's already on the same side, you just do exactly what it's telling you to do. 7 minus 3x. So what's 7x minus 3x? 4x. Minus 8 is equal to 24. Now what would I do, Anna?
You would add 8 to negative 8 and 24.
Very good. Add 8 to both sides, and I get 4x is equal to 32. Now what would I do, Megan? Divide by 4, and I get x is equal to 8. Perfect. Again, plug that in your calculator. Do 7 times 8 minus 3 times 8 minus 8, and see if it gives you 24. Your calculator will do order of operations for you. It'll work out everything, and if you get an answer other than 24, you know, okay, I need to backtrack. I need to figure out where I went wrong. Okay? Next one. What are my like terms, Tyler?
10, negative 7.
Perfect. Look, I've got 3 like terms in this problem. That's okay. We can still do it. So what I want to do is let's combine the ones that are on the same side first and then move one number. Instead of moving 2 numbers over, that's just going to be a little more work for ourselves. So 10 minus 7 is 3. Now I can say, all right, let's move the 3 over to combine with the negative 5. So Samantha, what am I going to do? We're right here. And how would I do that? Very good. Subtract 3 on both sides. Look right here. Same sign, so what do I do? Add and keep. 2y equals negative 8. Charles, what am I going to do now? Divide by 2 on both sides, and what does y equal? Negative 4. Very good. Make sure you pay attention to your signs, okay? Look at this next problem. You say, oh, fractions, I hate fractions, okay? Guess what? What have they given us in these fractions? Common denominators. What a gift. I don't even have to work very hard to figure out my fraction. So, let's combine like terms. Well, my like terms are 2/5 x minus 1/5 x. What's 2/5 minus 1/5? 1/5, because I keep my common denominator. 2 minus 1 is 1. So I get 1/5 x plus 9 is equal to negative 1. What would I do now, Haley? Perfect. Subtract 9. And I get 1/5 x is equal to what? Negative 10. Same signs, add and keep. Now, how would I get x by itself?
Multiplying by their reciprocal.
Okay, the reciprocal of 1/5 is 5 over 1, which is basically what? 5. I can write my 5 right there. See, that wasn't so bad on the fraction side, was it? So now I get x equals what? Negative 50. Okay. You want to multiply. All right. Okay. I'm going to skip this step and we're going to go straight on to example 3. Use distributive property. Use distributive property. Okay. There is a, like we said, that very first rule. Always combine like terms first. However, there is one trump card to that rule. And trump card means as soon as you see this, you know, no matter what, it goes to first priority. It has to be done first. And that is the distributive property. Anytime at all you see the distributive property, you have to do that first. If you combine like terms before you do distributive property, your answer will be wrong. You have to do distributive property first. So if you see that, it always comes first. And then we will combine like terms, okay? But that's the only time that that rule gets kind of pushed down, is when we've got distributive property. So if you remember, the example we used on distributive property was, if I were to bring in a bag of candy and say to one person in this class, would you like some candy? Everybody else in the class is going to go, hold on a second, we would like some candy. That's not fair. It's not fair to distribute a piece of candy to one person and not anybody else. So the same thing goes with distributive property. This 3 right here needs to be multiplied by everything inside parentheses. So if I were just to go, oh, 3 times x is 3x plus 4, that's not fair. That 3 did not get distributed to that 4. The 4 has missed out, okay? So we've got to do distributive property to everything inside parentheses. So I leave my 5x here because he just needs to hang out until we're getting ready to combine like terms. So 3 times x is 3x. 3 times 4 is 12 equals 28. Now I go back to that very first rule, always combine like terms. So I'm going to combine like terms. 5x plus 3x is 8x plus 12 equals 28. I've still got like terms here, so I'm going to subtract 12 on both sides. And I get 8x is equal to 16. Now I've just got a simple one-step equation. And what am I going to do, Manuel?
I'm going to divide by 8.
Perfect. Divide by 8 on both sides. And what does x equal? 2. Okay? Let's do this next problem here. Janae, what am I going to do first? Okay, I'm going to do distributive property because this 12 has to be distributed to everything in parentheses. So I'm going to let my 4x stay right there because he just hangs out. 12 times x is 12x. 12 times negative 3 is negative 36 equals 28. All right, what am I going to do now, Mackenzie? Combine like terms. Now, let me tell you this, okay? Typically, we've been saying, okay, like in this first problem, 5x plus 3x, or we would say 4x plus 12x. But would it be wrong if I went ahead and said, okay, let's add 36 to this side? Nope. You can combine whichever like terms you want first. It does not matter what order you combine those in. So let's do that first. So now I've got 4x plus 12x equals 64. Now I can combine 4x and 12x and get 16x equals 64. I'm going to cut out, or my answer right here, this step, is going to be the exact same whether or not I added 4 and 12x first and then added 36 on both sides, or I did it the opposite way. You're always going to end up, as long as you do your math right, with the exact same thing. So it doesn't matter what order you do it in, okay? Now what would I do? Divide by 16. And I get x is equal to 4. Okay? Okay, the next example that we have is we want to distribute a negative. Okay? This is important. This is very, very important. So what I've got is I've got 4x minus 3 times the quantity of x minus 2 equals 21. Autumn, what am I going to distribute in this problem? The negative 3. Did everybody hear what she said? She called it a negative 3, which is exactly right. Because you may say, well, no. 3 is just being subtracted. Every number has a sign, and that sign is where? Directly in front of the number. So 3 is a negative number. And if you don't distribute a negative 3, whole problem is wrong. You're not going to get anything right because you didn't even do the first step correctly. So you've got to distribute the negative 3. So that means I'm going to multiply this negative 3 times x, but also negative 3 times negative 2. So I write 4x Negative 3 times x is negative 3x. Negative 3 times negative 2 is what? Positive 6. That's where most people get that wrong. Because they just go, oh, it's just going to be minus 6. No. Negative 3 times negative 2 is positive 6. And that's where you go wrong, and then your whole problem is thrown off because you won't get the right answer. Okay? And it's not even like you're going to get the right answer, you just have the wrong sign. No, you'll get a totally different number. All right? What would I do now? Dean? Okay, I can subtract 6 from both sides. And I get 4x minus 3x is equal to 15. Now what would I do, Megan? Combine like terms. 4x minus 3x is 1x. Now look at this problem right here. 1x is equal to 15. Do I need to divide by 1? No. Because the reason why anything divided by 1 is always itself. So if I do 15 divided by 1, it's still going to be 15. So there's no point in me having to do that. Now, if that makes you feel better, like I just got to do it because it just makes me feel like I really get the 1 out of the way, go for it. That's fine by me. But if you don't show me that last step, if you just box that in and say x is equal to 15, that's fine also. Okay, but just make sure you write x is equal to. Don't leave the 1 in front of it. Just erase the 1. Or, like I do, I just make it as part of my box. Okay? So, this next problem right here. I want you guys to do this one on your own. I want everyone to work on this next problem on their own. Alright, so let's see here. Jason, what would I do first in this next problem? Distributive property. So, read me out what I'm going to get.
2x minus 5x plus 45 equals 27.
Perfect. Plus 45 equals 27. Okay, Charles, what would I do now? Okay, which means? Very good. Negative 3x plus 45 equals 27. Elizabeth, what would I do now?
Divide by negative 2.
Have I combined all my like terms yet? Okay. What would I do, Anna? Help her out.
You would subtract 45 from both sides.
Very good. Subtract 45 from both sides first. And now I've got negative 3x is equal to negative 18. What would I do now, Betty?
You
Divide by negative 3 on both sides. And I get x is equal to positive 6. Two negatives in a fraction make a positive. Don't forget about that, okay? All right, now there's one other type of problem that I want you to write down that I did not give you on your notes, but I want you to know how to do. This problem right here. Everyone write this one down. All right. Once you write this problem down, do you see anything that needs to be distributed? Samantha? The negative sign, okay? You say, okay, that's just a really random negative sign sitting out there on the outside of parentheses. Guess what is there that they did not have to write? An understood one. What they're trying to do there is they're trying to see if you're paying attention, trip you up, because a lot of people will go, oh, okay, that just means it's 5x minus 15x minus 10 equals 20. If you were to do that, it's wrong because you did not distribute that negative 1. So anytime you see a negative sign on the outside of parentheses, go ahead and write a 1 there because then it's easy to pick out, oh, I need to do distributive property. So I distribute that negative 1 to everything. So now I have 5x minus 15x. What's negative 1 times negative 10? Plus 10 equals 20. Combine like terms. Negative 10x plus 10 is equal to 20. Subtract 10 on both sides. Negative 10x is equal to 10. And I just divide by negative 10 and I get x is equal to -1. Okay? So, anytime you see a negative sign on the outside of parentheses, go ahead and write a 1 there and distribute the -1. Okay, the last example that we're going to do today is if they ever want you to distribute a reciprocal. Now, I don't know about you, but I like to make my life as easy as possible. I'm not going to sit there and do a bunch of work that I don't have to do if I can get the exact same result by doing something easier, okay? That's the reciprocal, or I'm sorry, that's the fraction there, okay? They want you to distribute this fraction to everything. That's going to be a lot of work, a headache that I don't want to have to deal with, okay? In order to make your life so much easier, the only thing you have to do here is you can multiply by the reciprocal. What that will do, watch what it will do. The reciprocal of -6/5 is -5/6. I multiply, totally cancels out. That goes away. And you say, okay, well, how do you do that? Whatever I do to one side, I've got to do to the other. So I'm going to move and I'm going to write -5/6 times 66, and I'm going to write it over 1. Okay? So basically I just moved it from one side of the equation to the other. So this is going to be much easier to multiply together. 6 goes into 6 one time, 6 goes into 66 11. Multiply straight across and I get -55 is equal to x plus 3. Look how much easier that problem became. What's the only thing I got to do now? Subtract 3. I just saved myself a minimum, I'm not joking, probably about 10 minutes, okay? Because one of my other classes said, just show us what it would look like. I literally stopped working because it was taking too long and it was just too much work. I said, nope, we're not even going to finish this problem because you've got to distribute that, then you've got to combine like terms, and you've got to get common denominators, and you get these huge numbers and fractions, and you reduce, and da-da-da, and the list goes on, and you're sitting there like, I do not want to do this, and neither do I. Okay, so we just combine like terms, and I get x is equal to -58. Guess what? You say, well, will I still get the same answer because I changed the problem? Well, technically you changed the problem, but you didn't really because you just took whatever you had on one side and moved it to the other. That's totally legal, okay? So if I were to plug in -58, I would still get the same answer. I would still get that my fraction or that my answer checks out. I would still get 66 equals 66. And if you want to plug it back into your calculator and check, I suggest you do that. All right, so what should I do on this next problem to make my life easier? Multiply by the reciprocal. So I'm going to do 10/3, so that totally cancels out. But don't forget, this is the part people forget, is they just cancel that out. No, whatever you do to one side, you got to do to the other. So I multiply this side by 10/3. I can simplify because I've got a 3 here, which I make a 1, and the 12, which I make a 4. 10 times 4 is 40. I could write 40/1 if I wanted to, but 40/1 is just 40, so I just write it like that. And then I have x plus 2. And you say, well, what happened to the parentheses? Well, when I no longer have anything to distribute, I don't need the parentheses anymore. I can just drop them. Okay? So, last step, this becomes a nice, simple one-step equation, and I just subtract 2 on both sides, and I get x is equal to 38. And that would be my final answer. Again, if I were to plug it in, I would get that everything checks out and that I did all my work right. Okay? So that's how you would do these problems for lesson 3.3.